Hello, today I'd like to talk about what SDR programs I have developed related to drone and in which aspects SDR community can benefit from this mini drone project. Earlier this year, I have developed a lot of applications on PortaPack. It's an extension board for HackRF to make it running without a PC. The apps I did are mainly on the communication with radio equipment of drones, including GPS transmitting, PAL demodulation, BLE decoding, and NRF24L01 decoding. They are merged to Vertex Havoc firmware. He's the main contributor for the Havoc firmware. The project is actively maintained by Arid now and changes its name to Mayhem. I'm still contributing new functions to it. GPS module is often used to hold position of the drone. It is supported in original version of ymfc-32. GPS transmitting can be used to test GPS module indoor. A smartphone or U-block module would log on to this test signal and you will know the component working or not. PAL is one of the analog video standard. All the television used to broadcast under this standard. Some FPV drone also use it to send camera video wirelessly to the operator. BLE is short for Bluetooth Low Energy. Sometimes it's used to control mini drone. Operator can use their smartphones as a radio transmitter. My app on PortaPack can help you discover the MAC addresses of BLE equipment around you. NRF24L01 is more commonly used on mini drone. Most people design their custom radio transmitter and use this chip to send control signal to mini drone. In this short clip, two of these kind of chips are used to send telemetry data back to my computer. One is on the drone and the other one is plugged into USB port of the computer. Computer shows the status of the drone by decoding message of the NF module. And my app on PortaPack can intercept these messages. You can see the message on PortaPack shows E7, E7, E7. It is the address of this chip, which is the same in the setup of my computer. I developed those apps by combining the knowledge of digital signal processing from the SDR field and microcontroller developing I acquired from this ymfc project. I also modified PortaPack's firmware to enable internal microphone and speaker by analyzing the datasheet of AK4951 sound chip. It is quite similar as in Job Brookings' video when he was trying to use MPU 6050 for the flight controller program. According to the recommended schematic, to add internal microphone, I need to use pin 5, 6, and 7. They are microphone power supply 1, right channel analog input 1, and left channel analog input 1, respectively. There are internal switch and multiplexers controlling those pins, and I need to set registers to configure them. I set PMMP to 1 to enable the power supply and MPSEL to 0 to select microphone power 1. Then I set INL and INR all to 0, 0, which is default to enable left channel analog input 1 and right channel analog input 1. In the code is 0B00. 0B is indicating 00 is a binary number. By designing the schematic and PCB of ymfc-mini-drone, I also acquired the knowledge of designing circuit board. I have recently designed and tested my own version of rtl-sdr. As an SDR hobbyist, designing my own board and firmware is much more satisfying than playing with existing software in user space. By sharing this project, I hope more SDR hobbyists would benefit from it.
但如果说要去很远的地方，要去很多天，怎么呢？
提着，
他提着，
硬提着，
或者是用快递先把要用的东西寄走。
那还要什么想？
As you can see, designing this mini drone isn't much different from designing rtl-sdr. Supporting this project, you will not only get a product per se, but also obtaining the knowledge of designing your own hardware and firmware. Thanks for watching.